Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon. Welcome to Do the Math. I'm Michael.
And I'm Scott.
I'm Presley.
I'm Kaylee. For math homework, help call in Bakersfield 636-4357. Everywhere else 1-866-636-6284. Email dothemath@kern.org.
We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
There you go. Nicely done. So, Presley, where do you go to school and what grade are you in?
I go to Highgate Elementary and I'm in 5th grade.
All right. So, how is 5th grade going so far?
Pretty good.
What's so good about it?
I like my teacher and my friends and I'm pretty good at math, so I like the math we are doing right now.
Okay, good. So, other than math, I mean, because you're on Do the Math today, I mean, is math something that you like more than other subjects, or?
It's my favorite subject.
So, why is math your favorite?
Because I feel like for me it's just easier than other things.
So you kind of get it? Mm-hmm. Do you always get it the way that your instructor shows you or the book, or do you have kind of your own methods of doing things sometimes?
Sometimes I have my own methods, and sometimes it makes sense when other people show me.
Okay, good. Well, that, there's no one right way or only one way to do all the different types of math that there are, right? Mm-hmm. So, Kaylee, where do you go to school and what grade are you in?
I go to Warren Junior High and I'm in 8th grade.
All right, and 8th grade is going well?
Yeah.
So you're getting ready to go to high school next year?
Yeah.
So what is one thing you're looking forward to when you go to high school?
Making new friends and getting to meet all the new teachers that I don't know.
Okay.
Right now.
Well, yeah. I mean, just like when you went to junior high, you were probably a little nervous at first, right? But you made a lot of new friends because you got people from different schools coming in.
Yeah.
Same thing will be happening when you go to high school.
Right.
Do you know where you'll be attending yet?
It's either Liberty or BCHS.
All right. So one of those two schools.
Yeah.
All right. Good. And what kind of math are you doing in school right now?
We're learning functions.
And
as
you
of right now.
like that? You feeling comfortable with
Yeah.
it? Good. Well, that's important to do. All right. Are you girls ready to help me out with today's social media problem of the day? Mm-hmm. All right. Let's take a look at it together right now. So this, we're dealing with positive and negative numbers. And it says negative 15 plus negative 1 plus negative 5 plus 5. So between the two of you, how would you like to go about solving this? Would you like to go in order just from left to right? Or do you want to put things together? Do you see any place that you want to start?
Put all negative numbers together first.
Okay, so you want to put all the negative numbers.
Yeah.
So how many negative numbers are there?
3. 2, 3. Yeah.
You agree with that there's 3 of them?
Yeah.
Okay, all right. So which one is not negative?
The 5.
There's 2 of them up there.
The positive 5.
Okay, the positive 5, all right. So you want to put all of the negatives together. If you do that, what do you end up with?
Negative 21.
Negative 21, right? Good. So you have negative 21, and then you have a positive 5. So what do you do now?
You subtract 5 from the negative 21.
Why are we subtracting it? Because it says add 5.
Because if it's a positive, you
You can't add positives and negatives.
yeah.
You can't add positives and negatives? Well, it says negative 15 plus negative 1 plus, and then plus 5. So you're on the right track, and I know what you're trying to say. So you have negative 21 and a positive 5.
Mm-hmm.
Yeah.
So what would you like to do again? I'm sorry. You'd like to take away 5?
Yeah.
And what will the answer be then?
16. Wait.
D?
Yeah.
D.
D.
Okay. So we have negative 21. And we're going to take 5 off of that.
Yeah.
And we're going to end up at positive 16.
No, negative
No,
16.
Oh,
negative
neg-
16. So
okay,
A,
now which
A.
one is it? You gave me 16 first, and you both said yes. Now it's negative 16.
A.
Do you guys do this all the time when you're at home? Your sisters and you. You usually get your math together, right? Okay, so it's a big day for both of you. All right. So you had the idea, put all the negatives together, which is a good way of going about it. And then you took away 5 because you know that the positive 5 can't just keep adding to the negatives, right? So you saw 16, and the 16 is up there for a reason because a lot of kids might go 16 and answer it with D, right? And there's two 26s up there, a positive and a negative. Why do you think there's a 26 up there at all?
Because if you were to add the 5 to the negatives.
Right, because when you add negative 21, if you take 5 more to that, you're going to end up at 26, right? But you know that it's the right thing to do, as far as we think, to take that away and end up at negative 16. You both think that's correct?
Yeah.
All right, let's find out if negative 16 is correct. All right, there you go. See how easy that was? The first problem of the day all done. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, so today's Math in the News. So girls, all different types of math have to do with sequences and patterns. That's pretty much the basis for any type of mathematical problem that you're going to be doing for the rest of your life. There's always some sort of a pattern or sequence that is going to be taking place. Can you think of any patterns or sequences that you have heard that have to do with anything?
No.
Like math-wise?
Anything, yeah. Well, preferably math-wise. Yeah. If I said 1, 3, 5, 7, 9, what is
like
that?
Odds and
Well, you count by
evens.
odds, right? We're
Yeah.
just skipping by twos,
Yeah.
right? If I did 2, 4, 6, 8, I'm still skipping by twos, but 1 are odds, 1s are evens. Have you ever heard of anything, well, first of all, can you think of any sequences or patterns other than skip counting? Because I don't want you to go by 5s, by 6s, by 7s, by 8s.
No.
Have you ever heard of triangular numbers?
No.
Have you ever heard of square numbers?
Yeah.
Okay,
I
so
haven't.
so what do you know about square numbers?
You multiply the number by 2. Like, so if you had 5 squared, and it would be 5 times 5.
Right,
So,
and that would be a square number?
yeah.
Right, good, okay. Have you ever heard of anything where it's named after somebody?
Junior?
What is it?
Junior? Like,
Go ahead, say it again.
junior?
Okay.
Like after somebody?
Oh, okay.
Is that what you're saying?
So I know, okay. So have you ever heard of a mathematical sequence or pattern that is associated with a specific person? Like, have you ever heard of Pythagoras? The Pythagorean theorem.
Yeah.
Okay, you have heard of that. Do you remember at all why you heard it or what it meant, or can you remember anything at all about that? The Pythagorean theorem? Does a squared plus b squared equals c squared sound familiar at all?
Oh, yeah.
Okay, so with triangles, okay, you're going to hear that stuff. There's a bunch of different sequences. Have you ever heard of the Fibonacci sequence?
No.
Oh, well, it's an even bigger day for you ladies right now, so here we go. So the Fibonacci sequence is a sequence in which each number is the sum of the two preceding ones. So here's the Fibonacci sequence right here. 1, 1, 2, 3, 5, 8, 13, 21, and it keeps going. All right? So if I take the first two numbers, 1 and 1, and I add them, what do I get?
So what's 1 and 2? What's 1 and 1? What's 1 and 1?
You guys know what 1 and 1 is?
Yeah.
Yeah, I know what she's trying to tell me. She's trying to tell me to get it larger on the screen, and I'm just
was the
worrying about
question?
this right now.
What's 1?
So what's 1 plus 1?
Oh, 2.
2.
Okay, so we're taking a look at the first two numbers.
Yeah.
All right, right here. 1 and 1 is 2. Now we take the 2 and add the previous number, which was a 1. So what's 1 plus 2?
3.
3. Now we take a look at the next two numbers. 2 plus 3 is,
5.
do you see the sequence?
Yeah.
So now what's 3 plus 5?
8.
So now 5 plus 8,
13.
So you see how the sequence goes. So now let's see if you can figure out the next number. We have the last two numbers are 13 and 21. What would be the next number?
33.
34.
Oh, 34.
34,
Yeah.
right? So this, have you ever seen this yet? Because you're in 8th grade. I don't know if you may have seen this yet. All right? You're going to. Okay, I promise both of you, by the time you're out of high school, you're going to see this in some math problems. You're going to hear about Fibonacci again. Fibonacci sequence in math also occurs naturally. Okay, so here you saw this spiral, and you can see how the numbers are going. All right, so in nature, you've got a spiral also. This is the Fibonacci sequence occurring naturally in nature. Okay, so here is something that I found the other day, and these are humpback whales hunting for fish. And can you see the Fibonacci sequence, the spiral right there? Okay, so the spiral is what we were looking at, and this is actually the video of it. So once the drone gets over, you'll see in the water, you see the spiral, right? Those are the bubbles that the whales are producing to get the fish into a certain spot, and you can see right in the middle, they come up and they can get them now, right? So they work out and then start working all their way in, but they're naturally doing this, and it comes out to look like the spiral with the Fibonacci sequence. That's pretty cool, don't you think?
Yeah.
I mean, I found that pretty amazing when I saw that, and I was like, we definitely have to put that on, do the math for the Math in the News, because that came out yesterday, and I was like, Fibonacci, here we go. So, you know the Fibonacci sequence now. It starts off with 1, and 1 is,
2.
okay, now you take the last two numbers I just said, 1 and 2 becomes,
3,
2 and 3 becomes,
5,
3 and 5 becomes,
8.
so you see how that sequence goes.
Yeah.
All right, and it occurs naturally in the world around us, and we just saw 2 humpback whales do it. Are you ready to do some work? All right, head on over to the board. Let's do your first problem. So, Kaylee, I'm sorry about that. Come on over here. We're going to make Presley do the work first. All right, are you all right with that?
Yeah.
All right. So, Presley, you can select either number 7, 8, 9, or 10.
I'll do 8.
So we have 7/8
You ready? All right.
plus 1/3. So explain to Scott how to solve that problem, or how you would like to start it, and if you need some assistance, he's right there with you.
Okay, so I write 3, and then I write 8 on the bottom, and I draw a line, and then I do another line, and then I skip count, and then
So you're looking at the two denominators of both fractions, right? And what's your goal when you're skip counting? What are you looking for?
the same denominator.
Okay,
the
so
same
you're looking at
number.
some point, 3 is going to end up with a number, and 8 is going to end up with a number when you skip count, and that's the number you're looking for. All right, go ahead. So you're going by 3s, right? Okay, so 8, 16. One more, 15. Oh, we're so close. Not quite. Got to keep going. $24. So we're hopeful now. Maybe we'll get to 24 on the 3 side. Good. 15, 18. Got 3 more after that. 21. 3 more after that. Hey, you got it.
So then
Well
we
done.
take these.
Yeah, those are the 2 numbers you're looking for. By the way, what's 8 times 3?
8 times 3.
24, right? Yeah. So there's a couple different ways to do it. And that's exactly what we were talking about at the beginning. You don't always have to have one way to do a problem. Some people might look at that and go, 8 times 3, 24, really fast. You skip counted and got the same thing. So there's no right or wrong way to go about it as long as you get to the same answer. All right, what are you going to do with that 24?
So I put that as the denominator for both.
Okay. So you're changing the original problem, or at least changing how it looks, right? Okay.
And then I have a plus sign. And then however many times I times that, I'll times the top number
Okay.
for the numerator.
So in other words, let's look at just the first one, right? Just the 7/8, so we're not too confused, right? And we'll make that one into that new fraction down there.
Okay.
Okay. How do you make 8 into 24? Times what?
7 times 3.
8
Oh, yeah.
times 3, right?
8
Gotcha.
times
So what you're saying is out loud, I like what you said there. I'm just going to write it down. Whatever you multiply on the bottom, you have to multiply on the top as well. So what's going to be your new numerator in the first one?
21.
That's it. You got it. Now we're going to do the same thing with the second one, right? The 1/3 is going to become this one. And don't worry about it being messy, right?
Okay.
Messy's fine. No problem there. That just means we're working hard.
8. So 1 times 8.
So hold on. What is 3 times 8?
24.
24, right? And that's where you got the 8 part, right? So again, I'm going to write down exactly what you said. 3 times 8 will give you 24 on the bottom. That means 1 times 8 on the top will not change the value of the fraction, but it'll change how it looks. So now, tell me first of all, why did you do that in the first place? Why didn't you just add everything up? Look, 7 plus 1 is 8, and 8 plus 3 is 11.
Because you can't add the denominator if it has an unlikely denominator.
That's exactly right. And I like the way you said that. They have to have like denominators. They can't have unlike denominators. What if you're multiplying? Would you have to get them the same? Say no.
No.
No, you don't. It's a little bit more straightforward, which is kind of nice. But I like what you've done here so far, which is good. So now what happens?
You add these.
Okay. Now what are you going to add? You going to add everything like we did before?
No, you just add the numerators.
Okay, just the numerators. Okay, so we like that. 29 over 24. Tell me about that answer a little bit.
So the numerator is bigger than the denominator, so I have
And what's
to
that called?
I forgot.
An improper fraction. Not quite proper, right? 29 over 24. I'm going to give you a little more room here.
Okay.
29 over 24. Nothing wrong with this answer. The other thing we want to look at too is this is an improper fraction. We don't like a bigger number on the top. The other thing is perhaps we can reduce it, right? Perhaps we can divide both numbers by a certain number. It doesn't matter what order you do that in. Maybe it works, maybe it doesn't. But let's talk about the improper part first. How do you want to make this into something more proper?
So I take 24 from 29.
Okay.
Can I write it?
Absolutely, go for it.
And I make it 1 whole.
Uh-huh.
And then my leftovers would be 5.
Gotcha.
And then I keep my denominator.
So where'd the 5 come from?
Whatever I had left over.
Okay,
from
so
taking
29 minus 24, right? And so if you were to rewrite this, basically what you're saying is 24 over 24 plus 5 over 24, right? Because this right here is 1. We're getting messy again, but that's all right. And then there's the 524 at the end. Now let's look at the 5 over 24. Can you reduce that? Is there a number that goes into 5 and 24 evenly? It's good to think about it a little bit. You could make a chart. We could go through a couple numbers. Does 2 go into 5?
Yeah.
Oh, it goes into it just not evenly, right?
Yeah.
2 doesn't go into it evenly. It goes into 24. Does 3 go into 5 evenly? No.
Oh, wait, no.
Not evenly, right? Does 4 go into 5 evenly? No. 4 goes into 24. That'd be nice. Does 5 go into 5 evenly? That works. Does 5 go into 24 evenly? Not going to work. So there's nothing we can really find that'll make that number reduced. But you got it into a proper fraction. Tell me about this answer. What would you call that in math vocabulary?
A proper fraction.
This is a proper fraction, 5 over 24, but what about the whole number with the fraction together? What do you call that?
Kind of stuck.
Yeah, a little bit, that's all right, no big deal. It's got 2 separate parts to it, okay? And you saw we were getting all crazy. This is a mixed number. It's 2 things mixed together. It's a whole number and a fraction together. And so knowing the vocabulary is not always ultimately essential, but it's nice to know because then if someone asks you, write me a mixed number, then you know what they're talking about, right? So now we have a little vocabulary. Improper fraction made into a mixed number, and we're pretty sure it's fully reduced.
There you go,
Good work.
nicely done. So that'll be the next thing that you'll be working on in class, but we're going to have Kaylee do one of those in a little bit. Both for your great effort so far today, Presley, you've got yourself a pass to CALM, so congratulations on that. And a little something, we were talking about Fibonacci, Pythagoras, and stuff like that. That all has to do with geometry. We'll talk a little bit about it now.
Hey everybody, Mickey here, and today we're going to look at geometric shapes and how we can utilize them to understand math in different ways. Now, a lot of students have a basic understanding of what these shapes are, and it starts at a very young age. And usually in kindergarten, when we just build things with different shapes. We put them together, and sometimes we notice, hey, certain shapes fit really well, and other shapes do not seem to match up very well at all. Very interesting. So at a young age, we use these geometric shapes to begin to understand how certain shapes fit together and what looks similar and what don't. As we get older though, we begin to identify what these shapes truly are. If I hold this shape here, a lot of students may say it's a triangle because they do see a three-sided figure, a triangle. A lot of students may turn it over and say, no, you're wrong, it's a square. What are you talking about? It's a square. And then they get older and realize it's not either of those. This is actually a pyramid because it is a three-dimensional object. It is a pyramid. Well, then students will say, but wait a minute, that looks different from this, and this is also a pyramid. So how can they be the same? Well, let's take a look over at these also. Both of these shapes have 6 sides. Top, bottom, front and back, inside and outside, or left and right. They have the same number of sides, but why aren't they the same? Why do they look different? We'll begin to look a little carefully. We notice the tops are squares. Good observation. But when I turn it on the side, one of these still has a square, but the other now has a rectangle. We begin to notice these differences as we get into higher grade levels when it's important to really distinguish one shape from another. And we do that by assessing sides, side length, and the number of sides. So let's jump back over here to our pyramids because they're both pyramids by definition. They have a base and they have sides that come to a single vertice at the top. First off, the number of differences I notice is that one of these has more sides than the other. The green one here has 4 sides, the red one has 3. Students don't really sometimes understand why does one have 4 sides and one have 3. The reasoning is the base, or the bottom of the pyramids. The one that had 4, the base, as you can see, is a square. A square has 4 sides that are equivalent in length, allowing this to be a square pyramid. Whereas my red one has a triangle or a 3-sided figure on the base, making it a triangular pyramid. That is my difference between these two shapes that I begin to learn in older grade levels. The same thing occurs with these 6-sided shapes. The blue one is by definition a cube because a cube has 6 sides that are all congruent or the exact same. And this is due to the fact that each side is a square. And if a square has 4 of the same side lengths, that means every other side length has to match, by definition making this a cube, a different type of 3-dimensional object that is more exact than this one, which we would call a rectangular prism. By definition, a cube is a rectangular prism, but a rectangle is not a cube. And a lot of students begin to have trouble with that because it goes into a more detailed understanding of 3-dimensional shapes. A cube has 6 sides that are all the exact same size, but a rectangular prism can have rectangles of different side lengths compared to their base. In this case, the base is a square, but my sides are rectangles. That means this cannot be a cube, only a rectangular prism. I jump over here, and a lot as we get older, students begin to have to calculate surface area and volume. Surface area is the measure of the outside and all the faces of a 3-dimensional object. As students get older, the surface area becomes pretty complex to understand and to calculate. The nice thing is, a lot of these shapes now, when we use them, I can open them. I'll pick one that's already open, that'll help us out. And they make them flat. We call that a surface area net, or a net for short. So usually when I look at this, I think of a can of soda or maybe a can of soup, and I have a can, or a cylinder would be the mathematical term for this shape. A cylinder. But if I need to calculate the surface area, or if I wanted to paint this or cover it, how much of something would I need? Well, the nice thing is I can take it out, lie it down flat, and all of a sudden my cylinder became 2 objects or 2 shapes I'm pretty aware of. I have a rectangle that actually creates the sides of the can or the cylinder, and I have 2 circles which create the top and bottom of the cylinder. Now instead of having this complex looking cylinder that I wonder, it has curves, how do I calculate the area? I truly now understand that a cylinder is really 2 separate shapes. It's a rectangle that folds around, a top and a bottom that are a circle. As long as I know my circle area formula and my rectangular area formula, I can calculate the surface area of this cylinder a lot easier than I thought it was previously. The same goes into a cone in later grade levels, or we can get more complex and have a hexagonal prism because my top and bottom are hexagons, 6 sides, and I notice each one is a rectangle. So same thing, if I were to fold this flat, I would notice it's a bunch of rectangles, 2 hexagons. If I can calculate the area of both of those, surface area becomes pretty simple to understand. Many different ways we can use 3-dimensional shapes out here in math. These are just a couple of the ways And of course, as you get older, you can always combine them and find different volumes, different surface areas. But for today, we'll stick with just surface area in identifying them. And remember, geometric shapes help more than you think.
All right, thanks to Mick for that on the manipulatives and some of the geometric shapes that most students work with. We do have phone tutors most Tuesdays and Wednesdays throughout the regular school year. Time now for a bonus feature that we like to have every once in a while. We're fortunate enough to be able to Skype with some folks at NASA and other places throughout the United States, and right here in Kern County, as a matter of fact. So first of all, from NASA, Nikki, how are you today?
I'm great. How are you doing?
I'm excellent. And we've also got Rebecca from NOAA. And how are you today?
I'm great too. Thanks.
Well, thank you both for being on the show with us this afternoon. I know you guys are pretty busy all of the time, but we have some pretty interesting stuff to talk about. So, Nikki, we're going to start with you. And you work at NASA, and we're talking about a project with a DC-8. Now, there are probably some students going, a DC-8, I assume it has something to do with aviation or space. So what is a DC-8, first of all?
Sure, yeah. So the DC-8 is NASA's Flying Science Laboratory. It's the largest aircraft that we fly science equipment on. We travel all over the world doing all kinds of research. And here you can see we've got a video of some of the equipment that we install on board the aircraft. My job as the engineer on board is to make sure that all of the equipment, all of the science equipment, the sensors that you can see being installed on the plane, that they're safe. And so that when we fly over cities, over the ocean, that we're going to be collecting all the data that we need to, and that we'll be doing it safely.
Okay, now when you talk
DC-8's
about
been around for a long time. Yeah.
all of the different equipment that goes on there, how long does it take to do the testing of that equipment in order to be able to put it on the DC-8?
Right. So we've actually got it down to a pretty quick. We can turn it around. We do 3 to 4 different science campaigns every year, sometimes as many as 6, where we have 30 or 35 different instruments. So we spend about a month installing all of the equipment, and then roughly 2 weeks or so testing it to make sure that it's all safe. That involves a couple of flights that we do right at the end of our installation period. Here you can see we're rolling some racks on board. Those racks have science equipment that we'll install into the floors, as you see there. And we put 15 or 16 of those racks on board the aircraft, and then we check to make sure that they're safe. We do a shake flight where we do a test flight. We're actually going to be doing our next shake flight tomorrow, in fact, where we'll go and we'll make sure that everything is safe, it's all bolted on properly, and that it's all been electrically checked out. And then next week, we'll have a whole bunch of scientists on board where we'll be doing all the electrical, and they'll be checking all of their instruments to make sure they're actually working.
Now, as far as the test flight goes, you said that that's coming up, and how long do you have to do that in order for you to be satisfied that everything's good?
We do our shake flight's only about 2 hours, and then our science check flights are really up to the science team. Rebecca, when we flew with her team, it was about a 4.5-hour flight was our science check flight, just to make sure that all the science teams are getting the data that they want, that their sensors are working, and that we're able to get the mission done when we're ready to actually start flying the science missions.
All right, so we've got the largest plane that you can have, right? You said it's the largest flying laboratory that there is available, right? And you've got all of these different instruments on there and things. And Rebecca, you are kind of working with all of the different scientists to gather the information. And what types of information are you looking at on the DC-8 when you're testing it with all the different measurements?
Yeah, so I was one of the science leads of the AROMA campaign. So that's the Atmospheric Emissions and Reactions Observed from Megacities to Marine Areas campaign. And so we had a variety of instruments on the plane that could measure different gases and aerosols, specifically for kind of research applications for air quality and climate. And we added over 30 different instruments, and then each of the scientists would be on the plane looking in real time as we flew how their instruments were doing. And that sometimes we would adjust the flight plans based on what we would see. And we would fly very low over urban areas of the U.S. And this campaign occurred last summer in 2023. So we flew over Los Angeles, Central Valley, Chicago, New York City, and Toronto. And as you can see from this figure, we're flying extremely low, right where all the emissions are for air quality and where we, live. And our goals were really to understand which emission sources are contributing most to urban air quality. And once we get all the data back and analyzed, we will feed that information to policymakers so that they can make more informed decisions, and hopefully that leads to improved air quality in cities across the United States.
Okay,
and
so it
hopefully
sounds
across
like
the world.
you've got a broad range of different cities that you've gone to. What is the
Exactly.
difference in the results when you are flying with cities closer to major water, so oceans and things like that, as opposed to in the middle of the country?
Yeah, that's a good question. Several of our cities, actually, most of them, have either a lake or a ocean next to them. So in many of the cases, this was impacting our results. It impacts a lot of the meteorological flow in the boundary layer heights. Sorry, that's a little too complex. So it whether you're close to water and stuff impacts the meteorology, which then feeds back on the chemistry and impacts air pollution and our understanding of everything.
Okay, so as far as conditions, because because you want to fly at the same altitude when you're flying in the different places to get the same, you want to keep that the same, I'm assuming. But the conditions have to be pretty ideal for you, because if you go, well, the weather conditions aren't allowing us to fly at this level, so we have to go to a different level, does that just make it longer in time that you have to do this, so you have to get back to that level, or you just kind of scrap it for the day and go, we have to go back at another time? And how involved is that? Because it's a lot of instrumentation that you have to get ready for this.
Yeah, that's a great question. So we had a whole team of air quality forecasters and also weather forecasters that basically prepared us, and we knew exactly kind of what conditions we were expecting. And we picked days that we would get good information. Air pollution generally is higher on days where there's a lot of sunlight, especially in the summer time periods. And so, we could actually focus on days that we didn't have too many clouds present. So that way we could go out to a city, fly around the city, without worrying about the meteorological conditions and, having to fly home. Although we did have some instances where we got a little bit close to clouds coming in and then had to leave a little bit early to consider that. Yeah.
And Rebecca, how many scientists do you have on board at one time?
We have about 30 instruments on board at a time, and each of them have 20 or it's probably like each of them have about 2 seats, or probably, I don't know actually, Nikki, how many scientists do we normally have board at a given time? Probably about 20 to 30, I would think. Is that right?
Okay, so one thing I wanted to know, and either of you can answer this, so let's say you've got 30 people on board testing things, you've got all these different instruments, and some scientists or whoever's working on one thing goes, I need 2 hours in order to gain a lot of good information, and somebody else goes, I only need 30 minutes, and somebody else goes, well, I need 4 hours. Are the people going to have to just go, listen, we're just going to accumulate more information because what we've got, we don't need any more, but this is just like bonus? So do all of the people go up all of the time, or do you break it up sometimes?
It depends on the instrument. Some instruments require kind of more direct involvement, and then they'll always fly. But some instruments can actually be programmed from the ground, and then they don't have to fly as often. Regarding conversations among scientists, that's always a little bit complicated. But there is a science lead, so I was one of the science leads of Aroma, and we tend to try to aggregate everyone's opinions and try to make decisions quickly so that we can convey that to the pilots to make sure that we fly in the right places.
All right, well, ladies, I do appreciate you taking some time to visit us. It is called Do the Math, and I'm sure that you ladies do quite a bit of math during the day on a regular basis, right?
We do.
Well, that's good to hear, because I know there are a lot of students interested in NASA and all of the different things STEM related, and it's just exciting, all of the different things, and it's a big thing. I know that a lot of students, and we've got a 5th grader and an 8th grader on the show today, and worrying about the atmosphere and the stuff in it is going to be a major concern, especially for students of that age. So once again, I do appreciate taking out some time to visit us this afternoon.
Happy to be here. Thanks.
Thanks.
Thank you. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays. We will be ending this season. I believe it is our 23rd season. Is that correct, John? Are we on 23? 23rd season this year, and we will be ending at the end of March, so right around spring break. That will be the end of live broadcast, but of course we'll have things all throughout the summer for you on our social media. Kaylee is an 8th grade student, and she is going to now, because I believe your sister ended up with a mixed number, correct? So we're going to have you now work with mixed numbers and see where this ends up, all right? Okay. So, Kaylee, 9, 10, or 11, which number would you like to do?
10.
10.
Good choice. Good
Here we
choice.
go. 6 and 6/7 minus 2 and 3/4. So go ahead, show Scott how you would solve this problem. If you need a little help, he's right there.
So I would multiply these and then add this.
Okay, so you have a mixed number, and what, you're going to change it up a little bit? What are you going to change it to?
An improper fraction.
Gotcha. So this is almost the reverse of what we did at the very end of the last problem,
Yeah.
right? Okay, so you're going to make the first one an improper. Times on the bottom, plus on the top. 7 times 6?
42.
Good. And then plus 6 more, right?
Plus 6.
Good.
It's 48.
Good.
And then I would do 48 over 7.
Gotcha. So you keep the same denominator. That's pretty important. Got to keep that same denominator. Only the numerator is changing, and we no longer have a mixed number.
Subtract. And then I would multiply these and add that.
Okay.
So 8 plus 3, 11
Uh-huh.
over 4.
And now we're kind of back to the same kind of problem we had before, where you have different denominators, right? Do you have a different way of finding the least common denominator here besides skip counting? Because we know there's more than one way to do it, right? How would you do it? You can skip count if you want. There's nothing wrong with it. It definitely worked in the last problem.
Yeah, I think I would do that.
Okay.
So
So you have a little chart, right? This is what I learned last time. You got to have a little chart. We'll do some skip counting. So 7 times 1 is 7. 7 times 2 is
14,
14. 7 times 3 is
21,
21. And then what's next?
28,
28. And one more? 7 times 5? 35. You're right. Well done. I'm impressed. All right, so let's skip count with 4s, right? 4 times 1 is 4. 4 times 2?
8,
8. 4 times 3?
12,
We're pretty close. Not quite, though. 4 times 4?
16,
4 times 5?
20,
Oh, we're hoping to make it. 4 times 6?
24,
24. And one more? 4 times 7?
28.
28. There it is. Well, that goes back to what we talked about in the last one. If you multiply those together, sometimes you end up with the number that you're looking for, right? 4 times 7. So our new denominator
It's 28.
is 28. Yeah, I like the way you did that.
So I would put 28, right?
Uh-huh.
And then
Sure does make it a little bit bigger numbers here, huh?
yeah,
So 7 times what number is 28?
4.
4, that's right. So that means we have to multiply the top number times 4. When you change this one, 4 times what number is 28?
7.
4 times 7, that's it. So on the top, we have to multiply this times 7. Let's do the first one first, right? We know 28's in the bottom, just like you wrote. Now you're going to have to maybe on the side do a 48 times 4, right? That's the number we're really looking for the top number.
Oh,
That's all right. We know it's a multiply. You can just put a 4 there.
That's going to be 192.
Ah, look at
I'm
that.
going to help you out with the calculator.
Giving you a
here.
little help
So
there. I like it.
192.
Good, 192 that goes on the top. And I think you can probably figure out the next one.
77.
What's the number that goes on the bottom? Oh, good. Okay. You got
sorry.
77 on the top and 28 on the bottom. All right, off we go. We got to do a little bit of subtraction now, right? Keeping the same denominator.
That'll be 115.
Oh, man, look at the help you're getting today. 115 over 28. What do we have? What's this called?
improper
An
fraction.
improper fraction. So we're back to going back the other way again, right? We'd love to be able to change this out a little bit.
So your whole number is going to be 4, because
nice.
28 is going to go in there 4 times. I'll let you guys figure out what's going to be left.
Okay, so what I like to tell my students is don't forget to put the same denominator in there, because that's going to stay the same, right?
So
we know
that's
it's going to be 4.
112.
Okay,
that you would
and
then-
4 times 28 is 112. So here's the number you have to figure out. 115 minus 112. What do you have left?
3.
Yeah, there you go. Would you like to check it? Because you can always check it, right? You can multiply the two numbers together and add 3, and you should get back to 115. So if you were asked to check it, you could always go backwards and forward, check it back and forth.
And if you guys want to do that, by all means, you can do that. But first, we're going to check this out about CSU Stanislaw.
In 1960, Stanislaus State College was established among the picturesque hills and waterways of California's sunny Central Valley to meet the needs of the region and contribute to its rapidly growing economy. Today, Stan State is an active and dynamic center of learning in a peaceful park-like setting. With campuses in Stockton and Turlock, both our locations offer a friendly college town feel just a short drive away from the bustling Bay Area. From their first steps on campus, faculty, students, and visitors alike are greeted by the Stan State warrior spirit.
Warrior spirit, I think, is never giving up and being resilient whenever you're faced with an obstacle.
It's having a hard work ethic, and it's sacrificing oneself for the benefit of the voiceless.
Warrior spirit is powerful, enduring, and uplifting.
I am proud to be a warrior because of the rich history Stan State has. The students today, what they're doing, what they're going through, the activism, it makes me proud to be a Stan State warrior. When I look at our future, it also makes me smile because I see bright colors of greatness.
Our dedicated professors recognize their students' different strengths and challenges and do everything they can to remove any barriers to success. And our tight-knit community and small class sizes encourage close student-faculty interaction.
I chose to teach at Stan State because we provide applied hands-on experiences for our students. And when you provide these experiences for our students, it prepares them for the real world.
I see the Stan State graduates who I got to know out there making a difference in the world. That is such an incredible feeling.
The more I found out about Stan State and the unique qualities of our student, our campus, our faculty, the more there was a great fit. The icing on the cake is that I'm actually born and raised in the Midwest, and this small town called Jenison actually was a farming town. As we were driving along the 99, it just felt like home. Stan State feels like home.
I decided to come to Stan State because it's close to home, and being a first-generation college student, that was very important to me, to be home and be supporting my family alongside getting my education.
The large majority, 74% of our students are first in their family to get a college degree. They represent to me these pioneers, these courageous students who are wanting to do something different and to aspire to greater success, and then going to make a difference, whether they be leaders or professionals working in different career paths.
I just finished my first year at Stanford. I'm working on my master's in physician assistant studies. I grew up here in the Central Valley, and there's really a lack of resources for underserved communities, and also they don't have access to health care. So I want to be able to provide that care to those communities.
One of the components I learned at Stan State was that I was just as intelligent as everybody else in the room, that I could be the most intelligent person in a room. I never knew that before. I'm a precocious person by nature, and I wanted all my questions answered. When I became a student at Stan State, I got that, and then some. So it broadened my horizons, it opened up doors I had no idea were there, and I flourished.
I think it's very unique here at Stan State that mentorship is part of its normal culture.
I always want to be available and accessible to students, to faculty, to staff, and others. So it is very important to me to give back and to connect and provide support to those who want to have mentorship or advice.
I actually just had lunch with Dr. Jun, the president at Stan State. So I really get the assistance, the guidance, and the friendship too of my mentor.
As an academic advisor, when I see students across my desk, I see myself. And that's the reason why I advise them with the passion that I do, is because I don't want them to fail. My experience at Stan State has never been one-dimensional. It's always been multifaceted because it's a culmination of a plethora of many positive feelings and emotions.
We welcome everyone who wants to do even more with their work and their lives to join us.
At Stan State, you belong.
You belong.
Another one in the CSU series, Stanislaus right there. 636-4357. Presley and Kaylee, 2 students, 5th and 8th grade, are in studio. Each have done a lovely problem so far. But now it's time to get to an even better problem. So here is the problem that you girls are going to work on. All right? In groups of 2, there's 1 left. Okay, so could the number be 5? If we're just having groups of 2, right? If I have a group of 2 and a group of 2 and there's 1 left, altogether there were 5. Does that make sense?
Yeah.
Okay. But if they're in groups of 3, there's 1 left. So if I took 5 and I have a group of 3, is there only 1 left?
No.
There's 2 left. So 5 we know is not going to be the answer, right? If there's 5s, there's 1 left. If there's groups of 6, there's 1 left. If they're in groups of 7, there are no pennies left over. There's nothing left. All right, so we're talking about pennies. It could be anything. All right. So remember, in groups of 2, 3, 5, and 6, there's 1 left over. And if you have them in groups of 7, there are no leftovers. How many pennies could there be? So you two head on over to the board, start writing down any information you'd like, and work together and see if you can figure out what the answer is.
2. There's 1 left. Okay.
And think out loud so we know what you're thinking in your head here. Do you want to write all those things on the board so you don't have to keep looking back and forth?
Yeah. Okay.
Sometimes it's good to draw pictures too. It's always kind of fun.
Okay.
Yeah.
Oh, G for groups. That's a good idea. So you can make a little chart or something, right?
Okay.
Yeah, there you go.
And then you can put leftover or whatever. So if there's a group of 2, there's 1 left.
Okay. There's 2.
Groups
and
of
then
2.
3, 5, 6, 7, 3.
Gotcha. I like it. This is a great organized way to do some work here.
And
There's 1, 1, 1, 1, 0.
Aha.
okay.
So how would you label the second
or like
row there?
just put an L.
Sure, L for leftover. Okay, so groups on the top, leftover on the bottom. Good way to start, so you don't have to keep referring back to all the words. It's kind of like translating all the words into math stuff. All right, well, we know for sure 5 doesn't work, right? Do you want to just try randomly another one, or do you have a systematic strategy way to go about making your next guess?
Not really.
So
We'll start somewhere. Let's say, let me ask you this question. Could it be an even number of pennies? Like
Not
4. Could it be 4?
no, not if there's 1 left.
Couldn't be 4, right? Could it be 6? Not if there's 1 left over, right? Could it be 20? Not if there's 1 left over, because there's always 1 left over.
Right.
So one requirement of the number of pennies we have so far is going to be not even.
Odd.
Odd. It has to be odd, right? There's using a little bit of logic in our data. So any number you guess, make sure it's odd.
Okay. So first 7, 2, 4, 6, 8, 2, 4, 6.
What are you thinking? What number are you thinking out loud so we can kind of see where your head's going here? Either one of you. Just take a random number, but it's got to be odd. We know it's got to be an odd number.
Random number.
Yeah, any number that's odd.
7.
7. Let's try 7. Sure.
Okay, so that would, if you 2, 4, 6, that'd be 6, and then there's 1 left over.
Right. So you'd have 3 groups of 2, 2, 2, 2. That'd be 6. And you'd have 1 left over. It'd be 7. It would work for 2. 7 would work for 2. Would it work for 3?
Well, there'd be
6, so it's 3 times
6. How come
2.
6? Tell me about why
3
6.
times 2.
Right. So 2 groups of 3 would be
you
6.
add 1.
1 left over. So far, so good.
And then
What about 5?
5, it wouldn't.
You can't.
How many people would be left over with 5?
3.
No.
You have 7.
2.
2 would be left over, and that doesn't work. So we got to pick another number. Probably bigger
11.
than 7. 11. Let's give it a shot.
Okay. So 2 times 5 is 10, with 1 left over.
11.
I like it.
So 3.
9.
So does it work with 3?
No.
How come? How many would you have left over with
So we
3?
would have 2 left over.
2 left over. 3 groups of 3. 3 times 3 is 9, plus 2 left over. Okay, so 11 doesn't work.
15. Do we try 15?
Sure, you can definitely try 15.
So that would be 14.
Now, let's look, once you try a number, if you're going to pick some random numbers, great idea, but look at which one of those things. Does any of those numbers go directly into 15 with no remainder? 5 does, and so does 3, and it says we have to have a remainder. So you know right away 15 isn't going to work, right?
Yeah.
Would you like a clue?
I like the clues, sure.
All right, let's give you a clue right now. So each of you were working with unlike denominators last time, right? And you were doing multiples to find a common denominator.
Yeah.
So if you find a multiple of one of those numbers, it's going to help you.
Okay.
So you want a multiple of one of those numbers, and that is going to be the answer. And I'm going to give you
Just
about
one?
30 seconds right now to start thinking about it, but you're going to have more time.
I like
Okay,
it. So
can we
which
write it down?
one, which number do you want a multiple of? Let me ask you this question. Which number does not have a remainder?
7.
7. That's the one we want multiples of, right?
Right, so that's the
There,
one I'm
that's
going to
the
have you
key
girls
right
start
there.
working on right
Yeah.
now. So you guys can start thinking about multiples of 7 and see if you come up with a number that satisfies all of those requirements. And right now, you're under a little pressure, but so are these guys.
Hi, my name is Mark Maxwell. I'm the director for the Fire Technology program here at CTech. And today I'm going to talk to you about the problem we need to solve getting water from a supply to the fire. And we'll talk about the pressures and the difficulties that we have to overcome to be able to get the appropriate nozzle flow and back pressure. In this chart here, or what you'll see, our formula is our pump discharge pressure, or sometimes called the engine pressure. And we need to calculate what our nozzle pressure is required to flow the rate that it's supposed to flow at the efficiency that the nozzle is designed to put out, whether it's a fog pattern or a straight stream. And then we have to add or minus the height or elevation that water needs to be pumped. Water's heavy, so it's going to take more pressure from the engine to push it uphill, and it's not going to take as much pressure as it flows downhill, as gravity pulls it downhill. So we have to take that off it. And then we have friction loss. There's a lot of turbulence, a lot of pressure that's being developed inside the hose as the pump is trying to push that volume of water through to the nozzle. And that creates a lot of friction in the hose, so we have to overcome that. So by using this formula, we're able to calculate what pressure the engine needs to pump at in order to deliver that flow to the nozzle. So let's go outside and take a look at it. Okay, so we've pulled the engine up to our hydrant. That's going to be our source for today's problem. And we'll have the students go ahead and hook us up to that supply line. Once they tighten it up, they'll turn the hydrant on. It's a green top, so it's capable of flowing 1,500 gallons of water per minute between 70 and 80 psi. So once this turns on, now it's going to hit inside the water shutoff inside the engine, so we need to open that up. Pump pressure isn't showing anything. The engine's not in pump yet, so I have to do that manually. So I'm going to step inside the engine, put it into pump, and then you'll see a change in the pressure. So this is a transfer valve. That's going to take the power that the motor's putting out and change it from the drive transmission to the pump transmission. I've got pressure now. Now you can see I'm reading 58 or 50 pounds of pressure on the pressure gauge. Now as soon as I open this valve, I'm going to get the pressure that comes from that hydrant. Jumps up to 140. So now I've got quite a bit more pressure inside without the engine having to change anything. But I still haven't solved my problem because I haven't been able to deliver that pressure to the nozzle yet. But we've got pretty good pressure coming off our display. So now I'm going to have the students pull up our discharge lines and show you how we can flow water to the nozzles themselves. Each one of these hoses are capable of flowing 200 gallons per minute at 80 psi. So I have to do the calculations to figure out what my engine pressure needs to be to get that 80 psi to each one of the nozzles with the same GPM flow that the nozzles require. We've got one line here. This is 100 feet. I've got two lines that are going here that are going to be 200 feet each. And with that deployment, I have to remember that I've got now 300 feet of hose out on the ground. So I have to calculate my engine pressure to my longest hose. What's going to happen is that means the nozzle that's on the short hose, I'm going to have to beam or slow that pressure down so I'm not over-pressurizing the nozzle. I've got two teams out here. One of them is going to have a different problem because the target's closer than the second team, and I'll show you by adding the pressure how I can throw much more water a much further distance. So I'm going to step over to the engine, charge those lines. I've got my cross lane number one, that's going to my first team on the other side. My second team right here. Water is now overcoming the friction loss of some of the old hose, but as it's going out to the nozzles, now I'm going to have them go ahead and discharge it. So they are at 113 psi. I'm not going to change anything until after we see what that problem is, if they're able to reach their target. Okay, so you guys go ahead and open the first one, and you should be able to see that the fog pattern, or the pattern that they have, the stream pattern, just barely reaches the target. So in order for me to compensate for that, you guys stay in one place, stay there. Change your GPM. So at the nozzle, they have the capability of increasing the amount of water flow. It doesn't change the pressure, it changes the water flow. Now you can see they've got quite a bit more reach on them. I didn't have to do anything at the pump, but they're maxed out. Now they can't reach that second cone. Okay, that's good right there. Now the second team, I'm going to increase the pressure and you guys will be able to reach that second cone. So now the second team, the same control, I need to jump it up to about 130, 140 psi. Okay, so now the pressure's changed. That should overcome the amount of friction loss that we had to that first hose. The second team having the same position, now they're at the same GPM setting, they should be able to reach that second cone. Okay, team two, go ahead. Much better reach on it. We solved the problem. We were able to get our water from one location to a second location by changing the pressure, even though they had a much greater distance to flow. That's math under pressure.
That's one example of math under pressure. Math under pressure even better with the two girls working on the math problem that they had to do. Good thing you were sisters, otherwise I'd see you out there duking it up with them. But anyway, so you had the problem where you had these groups and you needed one remainder alive, but one that didn't have any. So what number did you come up with?
91.
And that satisfies all of them. Do you see how that's a sequence or a pattern also?
Yeah.
Right, so that's a lot of what we did, sequences and patterns today. Did you girls learn a little something today?
Yeah.
Did you have fun today?
Yeah.
Good, that's the bottom line right there. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.